Well, I bet that'll wake you guys and girls up. Holy cow, we don't want that. Always remember to turn your speakers off, Lainey, or else you get some feedback. Oh, hello, Peter Hearn. How are you doing this evening? Hello, hello, everyone. We're going to get started here in just a second. I was running a little bit behind this evening. As you'll notice, we have no fancy introduction music or little intro. We can jump right into it. Tonight we're going to finish up and review the process in Vectric on once we have the file for the laptop stand and drawers imported, going through the Vectric software and ultimately what vectors we would get rid of, and see how it brings in the files into Vectric and what vectors we would get rid of, and then ultimately separating things out and creating toolpaths and all. So one of the things that we are going to look at is the way that I have changed the SketchUp program and in order to import those files and all. So the first thing we're going to do is we're going to kind of jump over and let me get things set up on the other screen here. All right, Peter, I'm sure there's other going to come in and join. You might be the only one with me tonight. Who knows? I'm not sure. Everybody else, if you come on in, jump in and say hi for sure. We're going to go ahead and kind of get started here. And we'll let everybody pop in as they go. This is just a follow-up class so we can move on to another project on Monday. So we're going to run today's class and all. All right. So the if we move over, make the move over to our other screen. Hello, Karen. Welcome. All right, before we make move over to the other screen, I've got to change my source. Bear with me a moment. Oh, come on. Stand by, guys and girls. A little bit of technical difficulties. There we go. Alrighty. So one of the things that you'll notice here looking at the SketchUp file is I went ahead and this will be the same way in the SketchUp file that I shared with you guys and girls if you did happen to download it and all. But I did go ahead and break down all the parts. I broke down the cabinet and the stand and everything, and I laid out all the parts, and I gave all of the parts the faces that I wanted imported into the Vectric software. I gave those particular faces a particular color, and this color of the faces is our color underscore CO5. That's the name of the color of the face and everything. And what that does is when I import the files into the Vectric software, it gives me the option of which way to bring it in. Do I want to just bring in the largest face, or do I want to bring in a particular color being the face of the component? And it allowed me to choose the option about bringing in the color. So what we're going to do is we're going to start off, and we're going to start from scratch. I've got already a finished file here, and I'm going to double check a couple things. 23 by 17. Okay. So we're going to open up a brand new clean Vectric window. We're going to create a new file. This is going to be a two-sided job that's going to be 23 inches in width, 17 inches wide, 3/4 inches thick. The purpose for this is to even make it to where it would fit on a mini carver if someone wanted to try it. With it being a double-sided job, I will be touching off on the waste board for both sides of the cut, and we will be starting off the bottom left corner of the design. When I do flip there's only 3 boards of all the parts and everything. There's only going to be 3 of them that need to be flipped. The rest of them are basically you just cut the one side. But when I do flip them over, I'm going to flip them along the y-axis in that flip direction from top to bottom along the y-axis. So we'll go ahead and click OK on that job setup. Now once we have that in, whenever we are importing a vector, and the SketchUp file would be considered a vector. When we're importing a vector, we're going to be under our file operations here, and we're going to go to our proper folder, and we're going to grab the laptop stand file. Now I also did create a DXF file for you guys and girls that don't have VCarve 9. You only have 8 or 8.5 that you can import those vector files. They're already cleaned up and everything for you, but what I'm doing is I'm bringing these files in raw. The VCarve file that I did provide to you in the Facebook group is a clean file, no cleanup required. It's ready to run. You just got to save the toolpaths. Double check the toolpaths, make sure that they are the settings and everything for your tools are fine, and then go. Because some of you may have a spindle, some of you may not. But now, with the layout of the imported data, by bringing this in, I can come in and I can choose a color option for what color face that I want to bring in. And once again, if we come back over here, I believe I said CO5, but I actually believe it is going to be CO9. Yeah, it is going to be CO9. CO5 was a file that I did last night for someone else, because that would be an absolute different color. So yeah, CO9 is what I'm looking for, and so we want to choose that option for color CO9 for the material face. I'm going to bring the parts in and with a gap of about 1 inch in between them all. I want it to create circles where SketchUp has created polygons. I want it to true fit circles to those SketchUp circles. And I want to keep my imported parts kind of grouped together, and I want to keep them near one another, their components. So we'll go ahead and click OK. And that will import all of our parts. Now, right away, I'm going to ungroup these individually here in a moment. But right away, one of the things that I'm going to do is I'm going to set aside or move the objects that I'm not going to cut on the CNC. I'm going to move them to their own layer. Right now, we have two layers, layer 1, which is our default layer, and then layer 0, which is the SketchUp file that was just brought in, all of those objects and everything. They're all sitting on layer 0 right now. Well, I'm going to add a layer, and I'm just going to call this 0.5 inch parts. I'm going to add a new layer called 0.125 inch parts, and then another layer called table saw parts, because there's going to be some things that I'm going to cut on my table saw rather than my CNC. And so now that I have those 3 layers created, I can now come in and select. So first off, this part here, and then all of these individual narrow runners throughout, all of these are 1/2 inch parts, and I believe that these are the only 1/2 inch parts in the project. So I'm going to go ahead and right click, and I'm going to move them to the 1/2 inch part layer, and I'm going to give that 1/2 inch part layer a color of kind of a olive green. So now you'll see those parts have changed colors on the screen. Now next is the 1/8 inch parts. And so for my 1/8 inch parts, I only have one here. And there are 3, but I've got it created in a way that it did not bring those other 3 into the mix. So I've got my 1/2 inch part here, which is my drawer bottom. So I'll go ahead and take and move that to a layer. And I said 1/2 inch, I meant 1/8 inch. My 1/8 inch part, it's an 1/8 inch part, it's my drawer bottom. So I'll go ahead and move that, and I'm going to give that color a color of kind of a blue and all, because eventually these are going to get moved out of the way or turned off, basically, because I don't want them brought into my individual sheets. So now that I have those created, now the parts that I'm going to cut on my table saw, the parts I really don't need to do on my CNC, because they're basically square cuts. I mean, all of these are square cuts, but you know, the drawer parts and things I can make on the CNC with all the grooves and everything. But the drawer fronts, this part here, this part here, this part here, my drawer fronts, my 3 drawer fronts, the square piece that the arm of the laptop stand mounts to, which is this part here, and then my actual laptop platen, you know, the laptop sits on, which is this part here. The parts that are in purple, I can cut those. Those are basically just square cuts. I can cut them on the table saw, which I will also do my 1/8 inch part on the table saw, that square piece. There's going to be 3 of those, even though there's only 1 showing here. But those I'm going to go ahead and move over to the layer called table saw parts, and I will give that layer a color of kind of a, let's go with kind of an orange color there. Okay, kind of a yellowish orange. And so now I can go ahead and turn off those 3 layers to hide those parts, and the only thing left behind are the parts for cutting and everything that I'm going to cut on the CNC. Now I'm going to go ahead and select all of those remaining parts, and we're going to go over to the nesting feature. Now if you have Vectric VCarve desktop or Cut2D or something like that, then you won't have the nesting feature. So you will just basically be moving these parts around, place them on different layers, create different layers, sheet 1, 2, 3, 4, 5, and then lay these out on different layers, on different layers that you can turn it off and on, and lay out all these parts so that it's almost like you're manually nesting them. But I'm going to use the automatic approach here with the nesting tool. Now in the nesting tool, I am going to have a tool diameter of 1/4 inch for 90% of these cuts. There is a few 3 or 4 cuts that are going to require an 1/8 inch end mill, so I'm going to be using a combination of my 1/4 inch end mill and my 1/8 inch end mill. And so for the nesting, I'm going to go ahead and set it up for the 1/4 inch end mill, because then I'll definitely have enough clearance and everything for the 1/8 inch end mill. I do want a clearance between the parts of about 5/8 of an inch. What that will do is that will give me, if 2 parts, cutting in between 2 parts, my 1/4 inch router bit cutting on the side of one part and then cutting on the side of another, those 2 cuts are going to equal a total of a 1/2 inch worth of material removed. And then I'll have an extra 1/8 inch of material in between those 2 cuts for tabs and what have you. So 5/8. And my border gap, well, that's what the distance is from the edge of my board. What's the gap distance from the edge of my board that I want for my parts. And I'm going to have a border gap of 0. If it wants to put them right up to the edge of the board, that's fine for me. We're going to rotate these parts for best fit 90 degrees. And we're going to nest from the bottom corner out along the x-axis, and we're going to go ahead and click preview. Now when we do that, it will create 10 sheets. Now the one thing that I'm missing here, 1, 2, 3, 4, 5, 6, there we go. I'm not missing them anymore. The one thing that I was missing last night was the rest of my drawers. For some reason I had only drawn, I thought I might accidentally delete them, but I fixed them. So I'm not missing anything. I thought I was missing my drawer fronts and all. Not my drawer fronts, but my drawer sides and things, but they're all here, every one of them. Good, good, good. All right, so now that I've nested this out, of my 23 by 17 inch sheet of material, 3/4 inch plywood or whatever I'm going to be making these out of, I have 10 sheets of that size that it's going to take me to cut all the parts out based on my spacing and the orientation and things. Now, if I reduce my spacing and all, I could probably move this loner part here that's all by itself. I could probably move that over to sheet 9, and I would just have a little bit of less room than 5/8 of an inch. I'll probably have like a 1/2 inch of room or something, but I could always move it over if I didn't want that 10th extra sheet. Now in order to do that, let's say that I did want to do that, I would have to first pull up sheet number 10. Okay, sheet number 10. And so in order to do that, when I'm on my nest parts, the active sheet right now is sheet number 1. If I come down here and go to sheet 10, it'll pull sheet 10 into the active window. And I could take this and I could select it, and I could right click and I could move to sheet, and I could move it to sheet 9. You'll see it disappears. So now if I pull up sheet 9, you will see the parts come up, and you'll see the part highlighted that I moved over there. And I could go ahead and position this, in some way to, see if I can get it to fit in a manner that it would, I would still have my spacing and stuff. And in order for me to have the manner and all, most likely it's going to require me to rotate it off the center of that part, rotated a total of 180 degrees. And then I can come in and probably pull that up here. Oops, maybe not. It's going to be quite tight. Something right about like that. And what that means is right here where these two parts are, as long as I have a 1/4 inch clearance, let's take a measurement and find out. As long as my bit can fit through there, that just means this one little part right here is not going to have any meat or anything. But let's take a horizontal measurement, and let's go from here to here, and plenty of room for our 1/4 inch bit to get into. So by doing that, I'm able to move that part over to sheet 9, and now it only requires 9 sheets for me to cut this out and things. And I'm not going to push my luck with any other sheets. So let's go ahead and open our nesting tool. Notice that I had to close the nesting tool. I had to close it in order to kind of work with the things. While the nesting tool is open, there's no, selecting or clicking or, moving and all that stuff. But I'm going to go ahead and let's go back to sheet 1. We're going to start from the beginning, and we're going to go ahead and lay this out and create our toolpaths. So when the Vectric software brings over our objects in this case, from SketchUp and things, well, it can't tell, like on this particular part here, this part that we're looking at, this is one of my cabinet sides. And so if we look here at the cabinet side, we've got these 3 grooves running along the part, and we also have this rabbet that's cut a little lower. The grooves are cut about 1/4 of an inch deep, and then the rabbet is cut 3/8 of an inch deep along one end of it and everything. Well, all this geometry, these rectangles, that make each one of these top surfaces, all of those individual rectangles are brought in. All of the rectangles that create the lower level of these grooves, and the rectangle that creates this dado. So all of these, and plus the rectangle that creates the boundary and everything, all of these additional vectors are brought in to the part. And right now the part's grouped together, so we can't see all of the individual vectors and all. But let's go ahead and ungroup that part. And now, as we click on them, we'll be able to see. And I'll try to zoom in so you can see the faint pink selection line on the screen, and hopefully it brings it up where you can kind of see that faint pink selection versus the orange that it is and all. And let's see if I can contrast that a little bit better by making everything on layer 0 black. All right. Maybe black might not be a better contrast because you might not be able to see that pink line. You might be able to see that pink line much better. Let me know what color combination worked better. Was the pink on orange or the pink on black? Whatever may work. But hopefully you'll be able to see that selected rectangle. And so this rectangle, along with these other rectangles, here that kind of created these top parts of the grooves. Well, we don't need those. Those are additional vectors. So what we will do is we will select them, and how you can tell there's an overlap is you get your pink dotted line with a solid line behind it. In this case, black solid line. So it kind of looks like just a kind of a dirty pinkish line and things. Let's see if I choose another color. Let's see if other than black, let's see if there's another color that presents itself better. There we go. That's actually pretty decent. So we can see the selected vectors. Yeah, let's go a little bit darker. So now we can at least see the dotted lines. Okay, we can see the rectangles. And we should still be able to see our vectors, you know, that blue. So you should still be able to see, now you should be able to see kind of that highlighted area, that highlighted the rectangles. You should be able to identify where I'm clicking now by that color change and all. Well, these rectangles we don't need. They're extra vectors that were created in order to kind of create this three-dimensional part in a 2D dimensional environment. So what we will do is we will select them and we will delete them. And now you'll see I have just a pink line here with that blue is gone. You know, is my perimeter. You can see my perimeter now when I selected that. This rectangle here, we want this, but we want to get rid of this rectangle. So all my large rectangles I want to go through and I'm going to go ahead and delete. So delete that one. All right. And then click on the bottom of it, delete that one, and then lastly that one. So now I should have clean border going all the way around my outside border, and then I should have three nice clean groove vectors, rectangles and all. So we got rid of those additional vectors, and now on the end here I should have my vertical vector, which represents my rabbit. Okay, so now that I've cleaned up that vector and gotten rid of the ones that I don't need, I can go ahead and adjust my parts. Now when the router bit is coming in here and cutting, let's see if I can create a router here, a bit here. And what I will do is we will put this on a move to a layer. We're going to call this our bit, and we'll make it black so we can see it. But when my router is coming in here and cutting this pocket out, you know, for this groove and all, when it gets to the inside corner, to turn the corner to come around and turn this corner and come around, it's going to create a radius here on those rabbits, and I need a nice clean square cut. So what I'm going to do is move that out of the way. What I'm going to do is I'm going to extend these vectors beyond where they need to cut. And so we're going to go ahead and hold down our shift key, grab this in, and the shift key allows it to stretch on both sides, and I'm just going to extend it out ever so slightly. And I'm going to repeat that process for all three of my dado pocket vectors. Okay. Now my vertical vector, which is my rabbit here that gets cut to 3/8 of an inch deep, I'm going to click on that. I'm not going to hold my shift key for this first move, but I'm going to grab this left vector line here, and I'm going to pull that out a little bit because I want that router bit, this edge here is my profile cut, so I want the router bit to go beyond the profile so I get a nice clean edge on this outside edge. If I were to leave it right where it sits, then my router is going to pocket in between these two vector lines, and it's going to leave a rough fuzzy edge that's not cut or clean. So I want to extend this out ever so slightly so it goes beyond my boundary cut. Now I want to hold down my shift key and grab this top middle vector and pull that out so that it goes beyond the cut there to create that part. So now that I have my vectors adjusted properly for this, I'll go ahead and ungroup these two items so I can select everything. I'm ready to create the toolpath for sheet 1. So let's move over and do that. Let's get zoomed back in here. Alright, so my first is going to be my pocket cuts. Now I have two different depths. So there's going to be two separate pockets, a drilling operation, and a profile cut on this sheet. My 1/4 inch deep pockets are going to be the 3 grooves. My 3/8 inch deep pocket is going to be the end rabbet. I've got a drilling operation for the through holes on these two parts here. And then I have my final cutout. Okay, so that's going to be the 3 toolpaths for sheet 1. So let's start with our pocket cut first. We're going to create our pocket cut. This is going to cut to a depth of 1/4 of an inch. I will be using a 1/4 inch end mill for this cut. And I want to select the 3 vectors associated with this cut. I am going to name these because we're going to end up with a ton of toolpaths for all 10 of these sheets. So I will name them by sheet number. Sheet 1, pocket 1, and then a 0.25 end mill. And so, because I don't care what, pocket 1, pocket 2, pocket 3 is how I'm going to number those and all, but sheet 1 and the bit and everything, that's going to be important. So let's go ahead and calculate that toolpath. Okay, so now that's created that. So let's go back and let's go ahead and create our second pocket. And this one is going to be cutting 3/8 of an inch deep. Too many decimal points there. And this is going to be for the end rabbet here. Again, using the 1/4 inch end mill. Everything is the same except for I need to name this. This is going to be sheet 1 again. This is going to be pocket 2 and 0.25 end mill. If I wanted to name it like grooves or rabbits or what have you, I could, but this is going to be simple enough. Sheet 1, pocket 2 is the second pocket cut on sheet 1. And calculate that. And so moving on, and we'll preview all these after all of the toolpaths are created. So let's go back over to our 2D view. And now we've got a drilling operation, which are these 3 holes. And so that will be our drilling operation. And they are going to be cutting all the way through our material, 3/4 of an inch. With our 1/4 inch end mill, I will be using pecking, so it pulls that material out, goes down, cuts a little bit, pulls the material out, and cleans out that cut. And again, we're going to name this sheet 1, drill 1, and 0.25 end mill. Now, because most of these sheets are all using 1/4 inch end mill cuts, all of these toolpaths that I'm creating for sheet 1 can be run at the same time with one file. We're not running 5 different files. We're going to save these different toolpaths as one file. Let's go ahead and calculate that. All right. And then finally, our profile cuts. So we're going to go ahead and select all of our profiles, the 3 profiles, and it's going to be a profile cut, cutting all the way through our material. And we're going to be using our 1/4 inch end mill for this cut. We're going to be on the outside of the line, and we are going to add tabs for this part. So my tabs are going to be about a 1/4 inch in width, about an 1/8 inch thick. Go ahead and click Edit Tabs, and we're going to go ahead and add a tab along the side here of the outer border there. I'm going to add 2 tabs along the bottom of this part and 1 right in the middle, and I'm going to add 2 tabs diagonally here on this part. And so that will be enough tabs to hold these in place. So we'll go ahead and close that, and we're going to name this. This is going to be sheet 1 profile cut 1 and 0.25 in mil to 0.25 em in mil, and calculate that. Now we can go ahead and preview all the toolpaths for this cut. So let's go ahead and preview this. We're going to have, first off, we're not going to have the profile cut first. Let's try that one more time. Preview visible toolpaths. All right, so our grooves are going to get cut first. They're cut to 1/4 of an inch deep. There's going to be 3 of those. And then our rabbet on the end. And then the drilling operation, and then finally the profile cut. The profile cut. With our tabs and everything. Okay. So now if we preview this cut, we can see that if I turn this part around, we can see that we have our 1/4 inch cut. Let's turn off the red color. There we go. We have our 1/4 inch deep cut here. We have our step down to our 3/8 inch rabbet. And when we extended those vectors out, that gave us these nice clean channels, you know, these nice clean dados. Had I left the vectors, you know, in their original state and not extended them out, then I would have little pieces of wood here creating a radius, you know, right here in the front of this channel, this you know, groove. So we've got that, and now all of our parts for sheet 1 are ready to go. Okay, so with that, we'll go ahead and reset this back to a blank board. Let's move over. And as we go through this, we have to keep coming back and opening up the nesting tool and going to our next sheet. So now our next sheet looks very similar to the first sheet, right? So this is sheet 2. Let's go back to sheet 1. Okay. And it's the same 2 parts, but it's the different side, you know, it's the left and the right side. So, you know, and so the part is, you know, changed very slightly. So basically we could, you know, just run sheet 1 twice, you know, to get our parts that we would need for that. We wouldn't need to create a whole toolpath, but we're going to do it again. So with that, we close our nesting, and let's go ahead and ungroup the vectors. I'll go ahead and ungroup all of them. And now we got to get rid of our rectangles, so we're going to right click and delete, or just hit the select and hit the delete key. And we got rid of our 4 rectangles, so now we should have a clean profile and 3 clean vectors, and then a clean rabbet here. Okay, so now let's go ahead and extend one more time, and this time I'm just gonna, since you know they're all 3 getting extended the same, I'm gonna just hold down my shift key and select all 3 of these, and that way I can just extend them all at the same time instead of doing them individually. So just bring those out like that. We'll select on this one, let go of the shift key, pull this one side out, then hold the shift key and pull both ends together out a little bit like that. And now we're ready to create the toolpath for sheet 2. Now here's where, because these toolpaths are very similar, these toolpaths, there's no sense, I mean, I could go through real quick and just create toolpaths, but what I'm going to do is I'm going to duplicate these guys here. So I'm going to go ahead and if I right click, I can click duplicate here, or we have an option, you know, to duplicate the toolpath there. But I'm going to go through and duplicate these guys. And then I'm going to take and move all the ones with the number 1 behind them. I'm just going to move them and group them together, because that's going to be my duplicates, the ones with the 1 at the end of the name and everything. Okay. Then I'm going to go in and right click and rename this, changing that 1 to a 2 and getting rid of this number 1 in the background. So rename this one. Change that 1 to a 2. Get rid of this 1 in the back end. Rename this. Change that. Get rid of that. And finally rename this one. Alright, now I can open up my Sheet 2 toolpath, and I can associate the vectors that I want to go with it, and just select them and calculate. Okay, come back over here, and that pocket number 2, open that up, select my vector and calculate. Come back to the 2D view, grab my drilling operation, open that up and grab my 3 holes, hold down the shift key and select all 3 of these and hit calculate, because they're all the same, these parts on these particular 2 sheets. And then my profile cut, go ahead and open that one up. Now on this one I do have to add tabs to it because it's not the same as the other vectors, so I'm going to go ahead and add tabs to this toolpath, and let me close that for a minute. Let me turn off these vectors here. Alright, let's go in there and add our tabs. Oh, first, before it I gotta select. Now I can edit tabs. Didn't have it selected. So we're going to do our same 4 tabs here, our same kind of 2 tabs and 1 on the front side. Oh, 1 over here and 1 over here. And we can go ahead and calculate this toolpath. So sheet 1 and 2 are relatively easy. So now we have our 4 toolpaths. No need to preview it. That's just a waste of time. It looks just like the other sheet did, but it's just the opposite side. So now let's go ahead and let's move on. Turn off these vectors here, and let's go over and move over to sheet 3. And we're going to kind of rinse and repeat this procedure. Now, let's take a look and see what sheet 3 is. Sheet 3, okay, very simple. We have 1 pocket cut, 1 profile cut. So 2 toolpaths for this sheet. Let's go ahead and ungroup this part here. Now, my router bit is going to be cutting a rabbet along this pocket, all the way around, and it's going to create an island here, raised up island in the middle, and it's going to cut this to 3/8 inch deep all the way around here, and that's the only cut on this. This area here on the right side is not touched, and the area in the middle is not touched. They're raised up. So in the case of this, I want to select my vector, which is this guy right here. And I want to double click on him, hold down my shift key and pull him out every little bit, so that way my router bit can travel when it's doing the pocket cut between these 2 areas and get plenty of room to go past my profile cut to give me that nice clean cut. And then over here on the back side only, we're going to extend it out just a little bit so that router bit can come and give me nice clean edges on my profile cut here. Now, this rectangle here on the front, we don't need it. That's an extra vector. That's just like, before. So we'll delete that. We don't need it. All we need are these 3 vectors here. So we're done with that. Let's go ahead and create the two toolpaths for sheet 3. So the first one's going to be the pocket cut. So between these 2 vectors here, it's going to be a pocket cut. It's going to be cutting 3/8 of an inch deep, 1/4 inch end mill. This is going to be sheet 3. Pocket 1.25 end mill, and calculate. And then finally, we'll turn that off. We'll go in and we'll create our profile cut. So our profile cut on our 3 profile parts. So profile cut, this is going to be cutting all the way through the material, 1/4 inch end mill. We are going to add tabs. So we're going to add a tab here, 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 and here. On this part, I'm just going to add a tab here, and there, there, and there. Move this over. I want it on the straight edge, not the rounding. So that'll be sufficient enough tabs for that part. And we'll go ahead, and this will be sheet 3. Profile cut 1.25 end mill, and calculate it. All right, so now if we preview our 2 toolpaths, if we preview those 2 toolpaths, we're going to have that pocket cut that is overly extended on the 3 sides, so that when, and it's going to cut to a depth of 3/8 of an inch, so that when our profile cut comes along, we get that nice clean dado. We don't have any radiuses in our cut or anything like that, and we will have that nice clean profile cut as it goes through and cuts down and everything. All right, now let's turn this to the side, and you can see that dado, basically rabbit, I guess you would call it. It's kind of a dado here, but rabbit on all 3 sides there that goes all the way around this part. And let's see if I can make this something a little bit lighter to be able to be seen. So there's our 3 parts for this cut. Okay, all right, so moving along, and it becomes really rinse and repeat pretty fast and things. So we can go ahead and move to sheet 4. What I want to get to now, sheet 4 is the bottom and 1 more of those cuts, so it's absolutely identical to what we just did. So I'm going to once again take sheet 3 and duplicate it. Duplicate the 2 cuts and move those duplicates down together. I'm going to rename this one sheet 4. Get rid of that 1 back there. Rename this one sheet 4. And then I can go ahead and ungroup this vector. I can come in here and select this vector, and once again do exactly what I did, rinse and repeat, extend that out on those 2 sides, holding the shift key so it does it evenly, and then let go of the shift and extend this one out a little bit. And now we can go ahead and create the pocket cut for that. Just calculate it. And then open up the profile cut, select our 2 profile vectors, edit the tabs, oops, I almost grabbed the wrong vector. This is my profile, not that one that I just extended. Shame, shame. All right, let's add our tabs to those two parts. Come on now. Okay, edit the tabs. We got 1, 2, 3, 4. And then again on this handle, I'll do 1 and 2. Move this one over a little bit. There we go. And it's already renamed, so all I have to do is hit calculate. Sheet 4 is done. So 6 more to go. And you get the idea. Now what I want to do is I want to jump to a sheet that has 2 sides to it. Because all of these sheets are the same size. And all of these sheets are most likely going to be run, in the same go around and everything. So we're going to be setting up our alignment pin holes and things for the 2-sided cuts and all. But let's move on. I think sheet 5, yes, sheet 5 does have a 2-sided part on there. So this one's going to be 2-sided. So what we're going to do is I'm going to bring a guideline over and snap to the edge of my board here. And a guideline is snapped to the edge of the board here on this corner. Okay, let's snap. There we go. And I'm going to move this guideline, or create another guideline relative to this one running along the horizontal link. I'm going to move it a 1/2 inch in my board. So we're going to go negative 0.5 relative, negative 1/2 inch away from this one, and create that new guide. And then on this guide here, the vertical guide, I'm going to do the same thing, relative, and it's going to be a positive 5 inches, and create that. That's going to create this center point here for me to put my 1/4 inch alignment pin hole. And let's size this up to 0.25 inches in diameter. And there we go. All right, now same thing. I'm going to drag this guide. I'm going to leave my 2 guides where the end ones, but the ones on the end of the board, I don't need them. So I'm going to drag them over to this side now at this end. And I'm going to grab this one that's on the edge of the board and drag it to this corner. And once again, we're going to make a relative guide 1/2 inch away from that. Oops, wrong guide. That should have been a negative number. So let's do that again. Negative 0.5 and create that guide. There we go. Let me delete this one. It didn't belong. And this guide here, this is a positive 5 inches. It's going up. Up is positive, down is negative. Right is positive, left is negative. Your X and Y, X minus, X positive, so on and so forth. So we'll create those 2 guides. And now these corner guides, I can go ahead and delete them. I don't need them because I have my guide here for my alignment pin hole. Okay, my 1/4 inch diameter circle. So now I've got my alignment pins for this, for flipping this board over. My alignment pin vectors and all. And for right now, I'm going to go ahead and view the guidelines. I'm going to turn them off. I'm going to leave them visible. I want to leave those there because I'm going to use them for the other sheets, so I don't have to redraw them. But I am going to turn the visibility off under the View tab. Guidelines, I'm just going to check on visible, guidelines visible, and uncheck that to hide them for the moment. And now I can go ahead and start cleaning up my vectors. Let's talk about this part here, and I believe this is no, I don't believe this is a 2-sided part. Bear with me a second. This is my jaw front. Let me go back to my SketchUp, my reference of my SketchUp here. Okay, it is a 2-sided part. The groove is on the back side and the rabbits are on the other side. That's this part right here. So the rabbit is on the back side of that part. Okay, so that's good.
All right, so let's go ahead and ungroup these. All these parts, I'm going to select every one of them and ungroup them. Okay, that's also the U on your keyboard. U for ungroup, G for group. All right, now this particular part here, this has its profile, and then it has these two rabbits coming out. The extra vector that was created was this rectangle right here in the middle. So we don't need that rectangle, so we're going to go ahead and delete it right off the bat. So we should have just our profile remaining. And then we should have two rabbit rectangles remaining over here. So once again, we're going to extend them. I'm going to go ahead and select both of these at the same time and grab this middle box, hold my shift key down, and extend both of them outward. And then one at a time, I'm going to go ahead and the right side, I'm just going to go out a little bit. And on the left side, I'm going to pull the left side out a little bit. So that way, again, you know the routine. So the router can create that nice clean rabbit on that edge. You never want to move the inside of the vector here because that's your the rabbit goes from the end of the profile to this point here on the right side. You never want to move that because then your parts will be all screwed up and they won't fit together. Now on this particular part, this groove here, this rectangle groove, it's going to go to the other side along with a copy of my profiles. And because I'm going to be flipping this board, most all of my vectors are going to be copied. All my borders, should I say, all my borders, not all the vectors, but all my borders are going to be copied to the other side, and because I'm going to cut them halfway down on one side, halfway down on the other side. So here we go. Let's see how we would approach that. So we're going to go ahead on this rectangle here that I've got selected. We're going to delete that. That's one of the ones that we do not need. Okay, and on the, let's kind of focus in on this a little bit. On this rectangle here, okay, you see how the profile, it didn't create the, the profile, right? The profile is it goes all the way out to here. It doesn't stop there, it goes all the way out to my rabbit, but it didn't create that rectangle. So if I look, the rectangle that I deleted, which I just undid, went all the way out to the edge. So that's the one we want to keep. We don't want to delete it. We want to delete the other one that's underneath it. We'll get to that one in just a moment by coming in here and, if I select this, that's the one we want to keep. But if I select this here, you see how it's selecting this end rectangle. It's not going to let me select the rectangle that I want at this particular moment. So we're going to have to kind of work with our vectors how they are. So let's go ahead and extend. Let's extend this one out for our rabbit cut. And on this end, we'll extend it out a little bit this way. Okay. Now, this profile cut, notice how there's a big old gap right here. It's not connecting. It's got to connect. It's got to go here, not there. So while I'm in, let's get this end down here. Got to sneak in right between these to grab that right proper vector. And let's extend that one out. There we go. Alright, so now that leaves us with our rabbit groove, which is what we want, and it leaves us with this rectangle and this rectangle. Well, they need to be joined together. So first thing we're going to do is jump into node editing, and a line between two nodes, control points, okay, that line between those 2 points is called a span, and therefore I do not need this span that runs between this point and this point down here. I don't need it. So I'm going to put my mouse right on the line and right click and delete that span. Get rid of it. Okay. Now on this rectangle here, I don't need the span on the left side. Right click, delete that span. And what that's done for me is it's given me these two open vectors that I can now join with a straight line to connect it up. If I collect it twice, it creates that full, complete, closed vector for my perimeter. Okay, that's my boundary, my profile cut. Alright, now my rabbit cut here, this little rabbit cut, this is going to be an 1/8 inch end mill cut, by the way, a little 1/8 inch groove. I'm going to go ahead and extend it out so my 1/8 inch bit can come and go through. And that is going to be on the other side. So let's go ahead and move some of our vectors to the other side. So let's start by selecting all of our boundaries. Okay, and we're going to and our alignment pinholes too. All right, and we're going to right click and copy to other side. Okay, copy to other side. And now that it's copied on that other side, I can go ahead and delete this vector, because it doesn't belong on this side, it's on the other side. And you can see the faint outline of it on the back side. If I switch over to my back side, you will see all of the vectors on the back side along with my groove. Okay, so let's flip back over here. Alright, now that we've done that, we're ready to create our tool paths. So most obvious is going to be our pocket cuts. I always start with the pocket cut, followed by the drilling operation, then the profile cut. It's only the 3 tool paths that there are. Now, both of these pocket cuts here for the big side piece and my drawers, they both get cut to a depth of 3/8 of an inch. So they're all going to fall under one tool path, so one pocket cut. All right. So 3/8 of an inch, 1/4 inch end mill. You see how it's kind of rinse and repeat because they're all the same depths. In this particular project, the depths are all the same. You know, we're either cutting 1/4 of an inch or 3 inch or 3/4. It's one of those three. So rinse and repeat. Same 1/4 inch end mill. All I need to do is name this. This is sheet 5. Now, this one has 2 sides to it, so I do add an additional bit of information into this. Side 1, and it's my pocket 1.25 end mill. And we'll go ahead and calculate that toolpath. All right. Now, my drilling operation. Okay, my drilling operation, alignment pinholes too, because they're getting cut to the no, I'm sorry, alignment pinholes are not getting cut to the same depth. What am I thinking? Let's do the alignment pinholes first. They're not getting cut all the way through. They're only getting cut 3/8 of an inch deep. So drilling operation, this is going to be drill 1. I'll just call it sheet 5, side 1. Align pin align pin 1.25 end mill. Just name it whatever, you know, it makes sense to you. Alignment pin 1. Okay, so we'll calculate that at 3/8 of an inch deep, 375. Still pecking, still the 1/4 inch end mill. Everything is the same there, so calculate that. All right, and now we're going to grab our other holes. And those are also going to be a drilling operation. And these are going to cut all the way through the material. Quarter-inch end mill. This is going to be sheet 5. Drill 2. 0.25 EM. Sheet 5. Side 1. Try to keep it consistent. If you're going to name them and things like that, keep the names consistent so it makes sense to you. You don't get confused when it comes to run these. So let's go ahead and calculate this toolpath. All right. And then finally, our profile cut. Now, what's going to be different for this is I'm not going to cut these profiles all the way through the material. I'm only going to cut them halfway through because I'm flipping this board over, and I'll finish up those profile cuts on the other side. So for these vectors, we're going to do a profile cut to a depth of 3/8 of an inch. 1/4 inch end mill on the outside of the line. I'm going to add tabs, even though I'm cutting all the way through, because those tabs are going to end up in the middle of the part. So I'm going to add tabs. We're going to get a tab here and here, a tab here and here, a tab here, 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 and here, and we'll do 1, 2, and just a third one over there. I don't need on that small part there. I don't need more. I don't need to go crazy. And let's go ahead, and this is going to be sheet 5. The only thing that's going to be the hardest part of this project is keeping the names, you know, like what sheet am I on and stuff like that. Sheet 5, and it says it right here underneath in a very faint gray wording. It shows you the sheet name. So sheet 5, side 1. Keep it consistent. This is my profile cut, and it's a 1/4 inch end mill, 0.25 end mill. All right, now when I finish this, automatically I'm going to automatically, before I jump to sheet 6 and all that stuff, I'm going to automatically switch over to the bottom side and go ahead and get those toolpaths created while I'm here. So I don't forget to not go back and do that. So in this case, we have a pocket cut. So we're going to go ahead and create that pocket cut. Now the difference with this pocket cut, it is 3/8 of an inch, but it's not a 1/4 inch end mill. It's the only, for the drawer bottoms, those are the only grooves that are going to be using an 1/8 inch end mill and all. So this is going to be sheet 5, side 2, pocket, and 0.125 end mill. So it's the only groove that gets a 1/8 inch end mill. Okay, so we're going to calculate that. Now, this is one thing you guys have got to really, if you are listening to this, really try to understand what I'm saying here. We're going to go ahead and create our alignment pin hole, and we're going to put it in order above this one, because the alignment pin holes are the first thing that gets cut. And they get cut in the wasteboard, not on the material. So let's go ahead and select our 2 alignment pin holes, and let's create that drilling toolpath. Now this one, because it is cutting into the wasteboard, we're only going to cut it about 1/4 of an inch deep into our wasteboard. And we're going to be touching off and zeroing off, and on our wasteboard. For this, we're going to go ahead and 1/4 inch end mill. I don't need to change that. This is going to be sheet 5. And it's going to be and I really want to name this so that it, everyone knows. And it's not side 2, this and that. This is going to be alignment pin waste board. Okay, alignment pin waste board, and then 0.25 end mill, something that just totally identifies that this is the cut for the waste board. Now, let's talk about this for a moment, okay? Let's click calculate to calculate it, but let's talk about what we're doing here. On this cut, on any of the cuts on my sheets, what did I set my job up to? I set the job up, if we close this and look at the material setup, I set the job up to touch off on the bottom of the machine bed on the wasteboard itself, right? Is my 0. The wasteboard itself is my 0. I'm going to be touching off on my wasteboard, not the top of my boards and everything. And so because the wasteboard is my 0, for these cuts, this 3/4 inch sheet of material, right? Because that's what my project's set up for, is 3/4 of an inch. Well, when I'm actually drilling the holes in the waste board, then I need to, when I touch off my Z, instead of that being 0, on the wasteboard, right? I'm just going to touch off to the wasteboard, and I'm going to set that Z as 0.75. I'm going to say that this point is 0.75 from 0 for this particular cut. So that way it cuts the holes in the top of my wasteboard 1/4 of an inch deep, instead of carving air. Because if I didn't, then when I go to run the toolpath, it would raise up and it would try to drill the holes in the air 3/4 inch above the wasteboard. So I got to touch off my tool sensor to the wasteboard, and let it know that is 0.75 inches. If you are using your tool sensor, don't forget to add an extra 0.010 of an inch if you're using your tool sensor, so it'd be a 0.76 is where you would be. I need you to try to understand that or grasp that in your mind. And if not, let me know, and in just a moment I will draw it out and kind of illustrate it for you in here. But it's important to know you have to touch off your Z on your wasteboard for this cut, but you have to change your Z and tell it that you're at 0.75, or if you're not using the touch pen or touch plate, or 0.76 if you are using the 0.010 of an inch touch plate. And I can illustrate that. But let's create the other toolpaths first. I'm going to move this up to the top of the list because that's the first one for sheet 5 that we do. So after the pocket cut, all we have are the profile cuts for this. So we've got our profile cuts. And so this will be our profile cut, cutting 3/8 of an inch deep, because remember on the other side it's already cut halfway through. 1/4 inch end mill. We're going to add tabs. Now, notice my tabs on side 2 didn't show up. And I want them to be in the same alignment as the tabs on the other side. Otherwise, it's not going to do me any good. I'm going to have a double the tabs and all, but they didn't show up. So how do we rectify this? Well, what we do is I'm going to come through and I'm going to select all of these profiles on this side, side 2, and I'm going to right click and delete them. I'm going to jump back over to side 1, and I'm going to select the profiles that I've already calculated a profile cut toolpath on, that I've already added tabs to during that calculation of that toolpath. I'm going to copy these to the other side, back over to the other side. And what that's done, if I switch back over to the other side now, what that's done for me is it's actually brought the tabs with it. So now if I click on add tabs to toolpath, you'll see they pop up, and that way my tabs are going to be aligned with one another on both sides. So with my vector selected, everything in here, let's go ahead and name this sheet 5 underscore, this is side 2, profile cut, and 0.25 in mil, and calculate. So now if I preview all the sides, we don't want that. Let's preview not all the sides. Let's reset that. Let's do that one more time. We're going to preview. Let's move over here. All the visible. toolpaths for this side. He was about to run down that whole list of toolpaths on the other side. We don't want that. So this is my halfway cut through side here. Let's flip over to back to side 1 and let's click on our sheet 5 toolpaths and preview those visible toolpaths. And in our 3D environment, when we're working with a two-sided job, we can actually view both sides at the same time in our 3D environment here, this 3D view. So now that we have our parts cut out, we can go ahead and we can literally flip this over and see, the bottom side and our top side, our rabbets and everything. Okay, so that takes care of sheet 5. It's all done. Now we're ready to move on. So that's how you would handle the two-sided part. And so we move on to sheet 6, and it's rinse and repeat. Now these are the drawer sides, and there's two sets of these. There's sheet 6 and sheet 7 are my drawer sides. So the same, I'm not going to repeat myself, the same steps that we would do here, we would do there. Now, if I turn my guidelines back on, my view guidelines, and I turn them back on visible, well, the first thing that I've got here for me is I've got my alignment places where I can put my alignment pins. So let's go ahead and do that first. We'll draw, because it is a two-sided part, so we'll draw our 1/4 inch diameter there. Let's change that to 0.25. And then down here in this corner, okay, so my alignment pin holes are done. They'll get copied to the other side along with the other vectors here in a moment, but now I can turn my guidelines off. We don't need them visible anymore. All right, so on this, let's go ahead and select all 3 of these parts and ungroup them, and let's see what vectors we got to get rid of and what we have to join. This one's got a couple of more cuts and stuff that we got to make, or deletion of spans, should I say. Let's ungroup this. And so on this part, if we look at it in SketchUp, if we come in and look at this part, that's this part here, there is the groove running along the bottom edge for the bottom part of the drawer, and then the 2 dados, and they're not rabbets because they're not at the end of the board, they're dados. There's 2 dado grooves here. So we've got that cut, and then on the bottom side is that single groove. That's going to be the drawer slide and everything. So let's go back over to our Vectric, and we're going to go ahead and look at what we're keeping and what we're removing. All right, so on my groove, that's going to be these center vectors, right? I want to keep that rectangle right there, I want to keep that, and that's most likely going to get on the other side. I'll cut that one on the other side. So what I'm going to do, just to kind of get it out of the way, is I'm not going to copy it, I'm going to move it. So I'm going to select this one, and that one, and I'm going to right click and move it to the other side. That's how I'm going to get rid of those 3. Now you'll see that there's no more middle rectangle vector. Now it's 2 separate vectors here, creating these lower rectangles and everything. This rectangle here, that's my groove. That's that dado that I need. So I want to keep that one. And so what I'm going to do is I'm going to go ahead and extend that one out right now, so my router bit can get past the profile. I'm going to do the same thing over here. I'm going to locate that rectangle there, and let's go ahead and extend it out. Okay. Now my rectangle here, this is that 1/8 inch groove. That one I definitely want to keep. So I'm going to go ahead and I'm going to extend this out. Now this one is only going to extend it out into this dado groove. All I need to do is clear this line, you know, when the router bit's cutting. So I'm not going to drag this all the way out here because this part doesn't get cut. So I'm gonna drag it out in this opening where this router bit has cleared out this pocket here. So you know, when it's cutting this out, you know, it's gonna be air here. So I want to keep that. Now I need to find my profile cut because I've got all the vectors that I wanted to keep. So now I just need to find my profile. So that's not my profile. That's a lower rectangle. What happens if I delete that? All right, so it's gone. All right. Now I've got this rectangle here. That's not my profile. But if I delete it, what happens? My line goes away, you know, down here. It's gone. And, you know, is that a bad thing? No. You know, we just got to, you know, figure out which of these vectors we're going to delete. Same thing here. This rectangle here I don't need. Delete it. This rectangle here, if I delete that, there you go. We don't have anything, you know. And so what I'm going to do is I'm going to delete these rectangles. Now I have these two ends with no connecting vector. Well, this is my profile here and here. Okay. So if I go into node editing and I delete this span right here, this one right here on this side, if I delete that, and I come over here, do the same thing with this one, making sure we're working on the right vector. Delete that span. Now essentially what I've done is I've got two open vectors, one on each end. And I can select both of those and join with a straight line. Once, join with a straight line twice to create my profile. And so now I should have my groove for my bottom of my drawer shelf. And I need to extend this side out. I must not have been holding my shift key, but pull that out just a little bit. I got my groove for my bottom shelf. I've got my two dados here, and that's what the front and the back snap into. That's a locking kind of rabbit. So I got those two, and then I have my profile cut. That's the only three vectors I need for these. All the rest of them were extras that were created by the Vectric software when it was imported, and we don't need them. Get rid of them. So same thing here. This rectangle we're going to go ahead and delete. This rectangle here we're going to go ahead and delete. This rectangle here we're going to delete. And this rectangle here we're going to delete. Okay. What that leaves me is this, and then my groove rectangle, groove rectangle, groove rectangle here. Those I want. So let's do the ends first. Might as well jump on them first. We're here. Go into node editing, delete that span. Same thing on this side, delete the inside span. Okay. While we're here, might as well select that one and join with a straight line once, twice. Okay, done. Now we can take our rabbits or dados, vectors, and we can go ahead and I'm going to do them both at the same time. If I hold my shift key down, I can pull them both out a little bit at the same time. And then on this one here, if I hold my shift key and grab this middle, I can extend it out, and it should do both sides evenly, which it did. Wonderful. And that's done. And so since it's the same three parts, we know now what vectors we're keeping, what we're getting rid of. So we're deleting that one. We're going to go ahead and delete that one. Down here below, we're going to get rid of that one. This little one at the bottom. That's going to leave us with our groove and our vector and all, and then our two outside parts. Okay, so once again, node editing, delete this span. That just leaves these three sides here, 1, 2, and 3. All right, these three sides. Come over to this side. Node editing, delete the span. Okay, that leaves this side. Now node editing is under the edit object tools. It's the second icon on the first row. So if I select both of these open vectors that I just created and join with a straight line once, twice, done. Now Notice something here. Vectric threw us a little bit of a loop. Let's extend this one out because that one's ready to go. But notice over here, Vectric kind of threw us a curveball, and it didn't, separate these two vectors here. It kind of made them one. Okay, not a problem. We just have to go into node editing, and we've got to right click and cut the vector here, cut it here, and then with that vector cut and selected, we just need to join that together with a straight line. And then this one we need to join with a straight line. And now we've separated the two, so they're no longer joined together. So we can go ahead and extend this out. And we can go ahead and extend this out. So we just had one little difference, one little change, because Vector didn't create that, those two as separate vectors. So we just had to come in and make that change. So now with that done, we are ready to create the toolpaths for sheet 5. And then everything that we just did here is rinse and repeat. Or sheet 6, I'm sorry, we're on sheet 6. But everything that we did here is exactly 100% the same steps for sheet 7. Because if we look at sheet 7, it's the other drawer, the other side, there's two of each. So it's going to be the same steps for that. So we're not going to repeat that process again for this, but you would if you were doing this in the Vectric software yourself. You would absolutely repeat the process. But let's go ahead and let's get our sheet 6 toolpaths done. So we're going to start off with, I'm going to start off with these little guys here because they are 1/8 inch cuts. So this is going to be a pocket cut, and it's going to be sheet 6. It is two-sided, so side 1, and this is my pocket 1 because there's going to be 2 pockets, and 0.25 in mil. And we'll go ahead and calculate that. All right, reset the preview back to a blank board. All right, before I get too far into all the toolpaths, let's go ahead and get the alignment pins created. I like those to be first in the list. So let's go. That's a drilling operation. This is going to be cutting 3/8 of an inch deep in my board. The side 1 gets cut in the board, side 2 gets cut in the waste board. So with our 1/4 inch end mill, now one of the things I got to go back and correct myself. I calculated that toolpath incorrectly on that first one, but let's get this fixed first. Sheet 6. Side 1 alignment pin underscore 0.25 in mil. Okay, click that. And I'm going to move that up in the list by 1 notch because I want it to be the first one for my sheet 6s. But let's go back into this one here. And on this one, I did change my end mill, but I named the toolpath 0.25 end mill, right? And that would confuse me. So I want to go back and change that and just recalculate that. Okay. So now we've got our 6 pockets for the rabbits here. And that is going to be a pocket cut. Now these go 3/8 of an inch deep as well. These are going to be a 1/4 inch end mill. The only time we use the 1/8 inch end mill is for those bottom grooves. So there's only a couple of cuts where we use the 1/8 inch end mill. The rest is all 1/4 inch. And this is going to be sheet 6. Side 1 pocket 2. It's my second pocket cut on that one. 0.25 EM. Very generic on the name, but it's enough to let me know what it is. And then finally, we have our profile cut. Okay, so we have our 3 profiles. Now, I'm going to go ahead and calculate them before I copy them to the other side because I want my profiles on the other side because they're only getting cut halfway through on this side, halfway through on the other side because it's a double it's a double-sided job, so it's only cutting halfway through. But I want to calculate these so I can create the tabs. That way when I copy them over to the other side, the tabs will be there. So let's go ahead and create the toolpath for this. So it's going to be a profile cut and 3/8 of an inch deep, 1/4 inch end mill outside of the line. We're going to add our tabs. And let's see here. We'll do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. Oh, let's see here. Looks good. Let's go ahead and name this sheet 6, side 1, profile cut 0.25 in mil. And we'll go ahead and calculate that toolpath. And William, thank you for pointing out to me the description on that end mill, 0.125 end mill. All right, so now that I've calculated that toolpath and everything, now I can go ahead while those vectors are selected and I can right click, and while I'm here I'm gonna, let's do that again. Let's select those 3 profiles. I'm gonna go ahead and take my alignment pinholes and copy them as well. So we're gonna, while they're all selected, right click and copy to the other side. All right, and now we're ready to switch over to the other side. Now on the other side, all we have are our 3 dados, or grooves, should I say. They're pockets, and they're going, I'm going to select all 3 of them together, and I'm going to extend, hold down my shift key, and I'm going to extend all of them out lengthwise. I want that bit to pass the profile cut. Okay, so while I have them selected, we'll go ahead and create our pocket cut. This is going to be a depth of cut of, it's going to go 0.25. This is a drawer slide groove for the drawer slide, so it's a 0.25 cut with our 1/4 inch end mill. We're going to go side, sheet 6, side 2, pocket, and 0.25 end mill. Okay, we'll calculate that. Okay. And let's do the alignment pins for the wasteboard. Do the alignment pins for the wasteboard. Let's get that in there. I like them to be first in the list. So this is going to be cutting 1/4 of an inch into the wasteboard. 0.25. Let's see here, 0.25 end mill. This is going to be sheet 6, alignment pin waste board, 0.25 end mill. All right, I want to move that up in the list. I want it at the front of the list. There you go. All right, so now the last only cut that we have is just the profile cut remaining. And so we will go ahead and select our 3 profiles. And this is going to be cutting 3/8 of an inch deep. It's going to be cutting 1/4 of an inch on the outside of the line. Add tabs. Bam, there's the tabs because we copied the vectors over from the other side with the tabs on them. So all I have to do is name this sheet 6, side 2, profile cut 0.25 end mill, and calculate. When it comes to naming the toolpaths, like I said, name them in a way that you know what they are, because if you look, if we switch back over to side 1, you see we already have we've got 6 sheets and all, about 3 or 4 toolpaths per sheet. So we're gaining a lot of toolpaths for side 1, and side 2 we only have 2 sheets because there's so far only 2 of them are 2-sided cuts. But you're gonna have a lot of toolpaths. So name them in a way that it's gonna make sense to you, because there's gonna be quite a bit. But now the thing about it is, there's actually not quite a bit, right? Because all of sheet 1 uses a 1/4-inch end mill, and so all of sheet 1's toolpaths can be saved as one file. We're running, it's not a 2-sided project. It's all using the 1/4-inch end mill. They all save as one file. So one file for that sheet. We're not running 4 separate toolpaths. We're running one file that does all of those individual toolpath operations. Now, bear with me for a second. If you've got to take a body break for a second, I've got to grab my mouse charger because my mouse just died and we have no movement or mouse action. So I got to grab it real quick. So 2 and 2, stand by. Okay, I'm back. Alright, let's get that mouse moving again. Let's get it plugged in. I killed the battery. There we go. Ta-da. So, now we have, sheet 6 is done, and both sides are complete. All the toolpaths are created, so we're ready to move on. Now, as I said, sheet 7 is the same as sheet 6, same steps. It's kind of rinse and repeat, and so I'm not gonna repeat this. The only thing that's missing from sheet 7 is if I turn the view or guidelines back on, because again it is a 2-sided job. It is the other side of the drawers and all. So we're gonna turn our guides back on and create our alignment pin holes, and they're 1/4-inch. Alignment pins, 0.25 diameter, and down here in the corner, 0.25 diameter, and click apply. Okay, then I can turn the guides off. Guides off. Don't want to delete them. I just want to turn them off. All right, and because of the way the software brought in the files, if I ungroup these, they should be exactly identical. So we have basically the same vectors and same things that we would do. We would select our 3 inner rectangles. We would move those to the other side, get rid of them. We've got delete that, delete that, delete the lower side, delete this guy. Down here at the end, node editing, delete the span. On this side, delete the span. Get out of node editing, hold down your shift key, select those 2 ends that you just cut open and join with a straight line. Come in here and extend this vector out a little. Here's our cut here. So we go into node editing, cut the vector, cut it there, join with a straight line, select this rectangle, join it with a straight line, and pull that out, and then pull that out. Done. Everything we just did on those same parts. Now notice how this part was the side where we had that vector, that extra work we had to do on it, where we had to cut it, and these down here have the closed rectangles and all. Notice on the other sheet 6, that part that we had to cut was at the bottom, and this one was at the top. That's because, you know, that's the mirror side, you know, it's the other side of the drawer. So it just, you know, I must have, when I drew up my vector, it must have been one particular side drawer that I had an issue with and stuff. And so then we would create our toolpaths for the same thing and stuff after we go through there. But we've already done the toolpaths for, you know, sheet 6. We would create the toolpaths for sheet 7. I'm not going to. You guys already have a finished file with all the toolpaths created. So we're going to move on to sheet 8 and see what we've got. All right, sheet 8 are, we've already done one of these drawers in sheet 5. So, you know, repeating the steps should not be hard. First things first is select all the vectors and ungroup them. And then on here we have this inner rectangle that we don't need. We delete it, delete it, delete that one, delete that one. That should leave us with, we have an outer rectangle here that if I delete this, it's going to get rid of, and there's no other rectangle over here for me to join with a straight line like we did before. So I have to leave that one. I've got to leave that one. And I'm going to let it come up to, you know, here and then across, but I don't need it to come across. So I'm going to go into node editing and delete the span here. Delete it. Okay. And then on this rectangle here, we're going to delete the span on this side. So it's the same thing that we just did with the other one, but in a long version, vertically instead of horizontally. But now notice something here. We don't have that far to travel, right? So we still select both vectors and join with a straight line once, twice, and that gives us that closed end. Now we should have our end vectors and our groove, and that's it. So you guys, you know, we've done this enough now that you should get it. Extend this out, and on this side, out past the profile line, down here. Get this extended out, and then one side only out past the profile line. And that one's done. I've got my profile cut. I got my 2 rabbit pockets at the end, and then my groove for my drawer at the bottom. All right. Now on this one, this is the front and back of the drawers. Okay. The other, you know, sheet 6 and sheet 7 were the sides. So if we look at that front and back of the drawers here, the rabbits are on one side and the grooves on the other. So it is going to be a 2-sided part. So we need to come back over here, and all the grooves, after we get all the vectors cleaned up, I can go ahead and select that groove, that groove, that groove, and that groove, and I can go ahead and move them to the other side. Just move them. Move to the other side. Okay, that gets rid of them. Now what that leaves me with is this vector and this vector, you know, these 2 rectangles. Well, node editing. Delete the inside span on the one on the right. Delete the inside span on the one on the left. And that leaves me with 2 open vectors. That one down there, you know, those 3 sides, and then this one. 3 sides. So click on those 2 and join with a straight line once, twice. Click the button twice. Our rectangles here, extend them out. Let go of the shift key, extend it up a little bit. You don't need to extend out very far, just a little bit. And same thing here. Okay, and so let's go ahead and extend this out. Oh, Notice I had my shift key held, you know, and now it's moving both. I don't want that, so I want to undo. I want to undo that and start back over. Never try to correct, always undo. Alright, and then stretch that out. Alright, now you can kind of see the two rectangles a little better, you know, basically, you know, the two separate rectangles here that we have to join into one. And in order to do that, these two inside lines right here, we need to remove, you know, these two inside lines here. So if I select on this and go into node editing, that inside line is a span between those two node points. We delete it. Same thing here. Delete that span. And that leaves us with two open vectors that we join together with a straight line once, twice. That's it. I mean, rinse and repeat, guys. Node editing. Delete the span. Maya, you're breathing heavy, girl. What's the matter with you? Delete the span. That heavy breathing you hear in the background is my dog. She's a fat little girl and she's got a lot of weight to carry around. Gotta get her on a diet. Okay. Alright, let's go ahead and expand this out a little bit. Let go of the shift key and expand that side out. And these, for this, all we have is our pocket cut toolpath and our profile cuts. And then this one is a two-sided job. So what do we need? We need our guidelines, view our guidelines, and we need our alignment pin holes. So I got these guides created so I can just go right to them each time, you know, they're pretty much exact. And if I did this exactly right, if I set myself up, you know, exactly right, I could, if I could make sure that on that first cut, my X and Y, my board all of my sheets land in the same exact spot every single time. And my 0 is on the bottom left corner in that same spot. I only have to set my X and Y one time for all 10 sheets if I'm running them all at the, you know, in the same day. And if I can make sure, if I get my setup just right, then I only need to drill the alignment pin holes in the wasteboard one time, you know, after the first sheet. Because, you know, sheet 2, if I'm, you know, working off that same X and Y, and when I flip this over, I could still use those same alignment pin holes because they're all identical. So I've got them all working off the same setup. So I don't have to sit there and drill a bunch of holes in my wasteboard. You know? Alright, so with those two drawn, we can turn the guidelines back off. And so I want to take these 4 profiles and my 2 holes, and I want to copy them to the other side, but I don't want to copy them until I get the profile toolpaths made because I want the tabs to go with it. So let's go ahead and make these toolpaths real quick. Let's do our pocket first. 1, 2, 3. No, let's do our alignment pin holes first. I keep saying I want to do those first. Alright, alignment pin holes, that's a drilling operation. Going 3/8 of an inch deep into our board. We're going to go, this is sheet 8. 2 more to go, sheet 8. This is drill 1. Actually, instead of drill 1, I'm going to call it alignment pin. And then 0.25 in mil, and calculate those two. All right, and then let's get our that is going to be a pocket cut for those vectors. They are 3/8 of an inch deep, 0.375, too many decimal points. And this is going to be again sheet 8. Pocket. Side 1. Let's go ahead. This is a two-sided job. Side 1. Let's get that identified in there. So calculate that. All right, and then our profile cuts. Now I can, create the profile cuts. Toolpaths. And this is cutting 3/8 of an inch deep because it's going to cut from both sides. 1/4 inch end mill. Everything is outside. Let's get our tabs added in. For this one, we're going to go 1, 2, 3, and right straight across. 4 and right straight across. 5 and straight across. Okay, 4 on each one. And let's go ahead and calculate that after we name it. Sheet 8. Profile. Side 1. Profile cut. And 0.25 in. Okay. All right. Now that that's done, now I just while they're still selected, might as well right click and copy to the other side. Immediately flip over to the other side. We've got our toolpaths here. Now on these grooves here, I'm going to select all of them, or these 3. I'm going to pull them out. They actually get pulled out right past the profile line, and this one here as well. Get pulled out past the profile line. Okay. All 4 of those get pulled out past the profile line. And so we've got the 4 pocket cuts. We've got our alignment pin holes. I don't see the alignment pins. Oops, let's switch back over real quick before we do anything, and let's grab this guy here and this guy here. Right click and copy to the other side. There they are. Alright, so this is, and I still, even though, just in case I have to do some of these sheets the next day, I still calculate the toolpaths for each of the ones that get cut into the waste board. So this one's going to be a drilling operation for those waste pin or alignment pin holes. Waste board is going to get cut 1/4 of an inch deep, not 3/8. And we're going to call this sheet 8 alignment pin waste board. I want that clear as day that that's for the waste board. 0.25 end mill. All right, with that done, let's get our pocket cuts. This is an 1/8 inch end mill. It's the only one that's, it's going to be an 1/8 inch end mill. So this pocket cut is cutting 3/8 of an inch deep with an 1/8 inch end mill. And sheet 8, side 2, pocket 1.125 end mill. And I want to calculate this, and I want to look at something here. Side 2, yep, okay, good. And now my profile cuts. So that's the only 2 cuts that I need to do is the pocket and the profile. Pocket and the profile. So profile cut, cutting 3/8 of an inch through the material. Everything is the same. Add tabs, bam, there they go. They pop right up. Sheet 8, side 2, Profile cut 0.25 end mill. Very consistent. Try to be consistent in naming and things. And so we have that. So now side 1 and side 2 are done for sheet 8. We can now, go on to sheet 9. Show sheet 9. So sheet 9 is all one. Oh, there's a two-sider. Yep, that's a two-sided cut. So we'll have to. This will be a two-sided cut sheet as well. But now we're not. You guys get the idea of creating the toolpaths and stuff, and clearing out the vectors and all that. But I want to talk to you about these guys. So in this part, in the SketchUp, I rounded over this front edge here. These, so it created all the rectangles. If we look at the SketchUp file of this part. Let's get to it down here. So I rounded over the edge on this part, and because of that, when it was imported into the Vectric software, Vectric created all of these rectangular lines. Now I would typically either sand and round this over, or round it over on the router table, or use my bandsaw to cut the edges off after it's glued up. I wouldn't, or you could just round it over, with a round over bit on the CNC. But I'd much rather, because these two parts get glued together to make one part. These two parts get glued together to make one part. 1.5 inch wide part and everything. And so before I do any rounding over and all, I want to, glue everything together in case I have to kind of do some trimming and clean up the edges or whatever, on the table saw or bandsaw or sander, whatever it may be. So really, these vectors are just, those are the vectors that you don't need. So let's ungroup these. And let's see how Vectric created our profiles for us. Well, we definitely need our rectangular grooves here. We definitely need our rectangular grooves here. And so I can identify them and separate them from the others. I'm going to go ahead and just extend them out now. They only get extended out long ways. So each of these get extended out. And what that does is it gets it off of this boundary line here so that it can help me identify, my profile. And that is not my profile. It stops here, and I need it to go all the way to here, Yet Vectric, created these little rectangles instead of, profile cuts and all. So I'm going to start at the very bottom, this little one, and delete it. Okay. So now if I select that, you see I have this rectangle here. Well, I'm going to need to keep that. Have to trim off some of the vectors and all to join them with, this one. But if we zoom in, so we're going to keep this on the end. But let's see here. This one here, we can delete it. This one here, we can delete it. This one here, we can delete it. That one, that one, that one, that one. All the way up to these, except for that one, not the last one, whatever I just selected. Let's see here. Let's see if I can delete those and delete that one. So I need this one. So I've got to join this vector with this vector, and they overlap each other. Okay, they overlap each other. And if I go on the other side of this rectangle, if I click here, I've got this vector that doesn't overlap, right? It doesn't overlap with the lower one. So rather than having to deal with overlapping lines and trying to cut them in the right place and all, I'm just going to work with this vector and this one. Okay? And I'll just join. I'll delete the span just like we did before. So let's go ahead and get rid of, I'm just selecting and getting rid of the vectors that we don't need. I'm going to delete that. Okay, so now I should end up with 3 rectangles at the bottom, my 3 grooves that are going to be cut 1/8 of an inch deep, and then this profile up here. So if we go into node editing, right here, this just like on the E, this first one, we're going to delete that span. Come over to the next one, delete that span. Come over to and select this one and delete that span. Alright, down here on my rectangles, we're going to delete that upper span. This rectangle here, we're going to delete this upper span. And this rectangle here, we're going to delete that upper span. Now, I can't do them all at one time. I have to do them at one at a time because it kind of follows around like a track. So I got to select this lower vector and this vector here and join with a straight line. One time. Now I can select this vector, join that with a straight line, select this vector, join that with a straight line, select this one, join with a straight line, this one. Now I can join with a straight line once, twice. Okay, so all I should have is a profile cut and my pocket cut for these 3 vectors. Okay. And so we would repeat that here as well. And now that we know what we just did and deleted on the first one, we can go ahead and get rid of, let's ungroup it. And we can go ahead and get rid of the vectors and everything, just, like we did before. Just grab them and delete them. Make it much quicker for ourselves. Let's go ahead and expand our little grooves out. Might as well while we're here. 1, 2, 3. We get rid of this vector, delete it. So again, we have our 3 rectangles, and then on the other side we've got that one. Node editing, delete the span, delete the span, select this and delete the span. On this side, delete it, delete that span, delete that span. Now we have to one at a time. So from here to here, join with a straight line, add this one to it, hold the shift key down, join with a straight line, hold the shift key down and add that one to it, join with a straight line, hold the shift key down, add this one to it, join with a straight line, and then on this last one add that to it holding the shift key and join with a straight line twice, and that finishes that off. Over here, very simple parts. If we ungroup this, we look at what we've got going on here. That's our profile going all the way around. We definitely want to keep that, but we've got our rectangle here. We're going to extend that out. That's our little groove. Okay, what does that leave us? We've got a profile that goes around, but there's something else underneath it. Could it be a second profile? What happens if I delete this? What do we end up with? We get this rectangle here and this rectangle here, right? So I don't want to delete that because that's my profile. And so if I come back, I have that. What I can do is, if I'm carefully cautious, I can come over and, all right, I love you, baby. You got to go outside. You're breathing too heavy. The microphone picks up a lot. She'll settle down here in a minute, guys. She gets excited. All right, so if I'm very, very careful, if I just use my up arrow key on my keyboard one time, move it up, all that does is it gets it off the, those 2 vectors, and I can go through and I can, hit delete, 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 and then I should be ended up with my profile cut and that. And the only thing that my hole is off now by 1 up arrow key, so I want to come back down, bring myself back down. If I would have selected my profile and that circle at the same time and moved up, then I could have just left it where it was, because these grooves are, they didn't move. So same thing here. Ungroup this, and if my rectangles, extend them out. This one here, extend it out. And I know that this line, this single line, see how there's no blue behind it? I know that that is my profile cut and everything else is in there. So if I come in here and if I select everything, except for that circle right there, select all of those vectors, I can turn off my two rectangles. I know what they are. I can turn off my profile by coming in here and seeing this single line right there. And the only thing left, turn off my circle, don't want to delete that, but the only thing left are those two vectors, or four vectors should I say, that I need to delete. Now I can right click and delete, and so that's another way of doing it, to end up with the same result, rather than the up down, with your arrow key or whatever. This guy here, ungroup him. I've got this rectangle here, doesn't belong. It gets deleted. My rectangle here gets extended out. This is my rabbit cut on this end. This is my rabbit cut on this end. This rectangle here gets copied, or moved, not copied, sorry, moved to the other side. Move to the other side. And then what does that leave me? That leaves me with these two rectangles. We go into node editing and we select this one. Right click and delete the span there. Select this one, right click and delete that span, and then come back and join with a straight line once, twice to close it off, and that finishes that up. But I want to create my profile toolpath for these parts, because these parts are going to get cut out in two separate steps, because it is a two-sided job. Just for this one drawer, it's got to be a two-sided job. If this, if I wanted to, I could switch it out with one of the other parts, but I'm already 9 sheets into a 10-sheet job, so I'm just going to go with it. I am going to turn my guidelines on, and I'm going to draw my alignment pinholes, since it is going to be a two-sided part. And then you guys get it. It's rinse and repeat, and that's the process of how you would kind of look at and go through your Vectric files if you're bringing files in from SketchUp. Let's go ahead and make this 0.25. Okay, turn my guidelines back off. And let's go ahead and make the toolpath. This is sheet 9. So let's get over here and make our toolpath. Let's start with our pocket cuts. Now all of these are 1/4 inch pocket cuts, so I can go ahead and grab every single one of these, because not only are they pocket cuts, but they're also all only 1/8 of an inch deep on these guys here. So all of these, okay. So on those parts, not my two ends. Those are 3/8 of an inch deep, but all of these are 1/8 of an inch deep. So we're going to go into our pocket cut. This is 0.125 inches deep. The reason why they're 1/8 of an inch deep, when the two parts get together, are glued together, that creates a 1/4 inch by 1/4 inch hole for a 1/4 inch bolt to slide through for locking or linking these links together and stuff and all. So for this, it is going to be a 1/4 inch end mill, and it's going to be sheet 9, side 1, pocket 1, 0.25 end mill. All right, now the two other pockets here, the only other two pockets here, those will be 3/8 of an inch deep. End mill, so all we got to do is name it sheet 9, side 1, point, pocket 2, 0.25 end mill. All right, and I've got my alignment pinholes. We'll move those to the top of that sheet 9 list, but these are going to go into the board because this is side 1. So let's create our drilling, cutting 3/8 of an inch deep into the board. Sheet 9, side 1, align, and I'm going to abbreviate 0.25 end mill, and calculate. Okay, then we got two other holes here that's got to get drilled all the way through. So another drilling operation. This is going to go all the way through 3/4 of an inch. And this is going to be sheet 9, side 1, drill 1.25 end mill. And then finally on this side of this two-sided sheet are profile cuts. And then what we'll do is when we calculate the profile cut, everything is the same. We're going to add tabs so that way we can copy them over. Let's see here. We'll go 1, 2. We'll do 1 on each end. We'll do 1 on each end here, and 2 on this side. 2 on this end here. 2 on this side. Let's go 1, 2, 3, and 2. 1, 2, 1, 2. All right. Sheet 9, side 1, 0.25 end mill. Profile cut, then 0.25 end mill. All right. So let's, now that we've done that, let's go ahead and turn those visible toolpaths off so we don't need to see all those check marks there. Okay, and let's go ahead and take our just the profiles of these parts and our alignment pinholes and copy them to the other side. That way, and the only the only reason we're doing this, we have, if we switch over to the other side, we only have this groove which gets extended out past the edges. And it gets extended out past the edges, and so that's just that one single pocket cut on this side, cutting 3/8 of an inch deep with an 1/8 inch end mill on this side, and this is sheet 9, side 2, 0.125. Whoops. Pocket 1. Calculate that. And let's go ahead and let's get our alignment pins, just in case we don't do this. You know, we need to do the alignment pins on a separate day or something like that for our wasteboard. Let's get those that toolpath created. I still create it for each and every one. You know, every board that we're going to be using, because there's no unless I set myself up to where I can do these all in the same run, and I have all my boards land in the same spot. Then I only need to drill my alignment pin holes once. But there's going to be that time where if I don't, I want to have that toolpath available for this sheet. So 0.25 deep. Sheet 9. Alignment. Pin. Waste board. Notice I didn't put side 2 because I know my alignment pin waste board is always going to be side 2. Okay, and then finally to finish this off, we've got these profile cuts, and that is it. So profile cut. This is 3/8 of an inch deep, 1/4 inch end mill. Everything is the same. Add tabs. Bam, the tabs will pop up. We can go ahead and sheet 9 _ side 2 profile cut and 0.25 end mill. All right. Now there's nothing on sheet 10. Remember, we moved this part over. Let's what do we got checked off that shouldn't be checked off? Oh, we got some sheet 8 stuff checked off there. Let's turn off. Okay. There's nothing on sheet 9 or 10. It's empty. So that, that's all there is to that and everything. And where we moved, these two parts, you see where the toolpath is, come together. It's going to cut both of those, and we have plenty of room in between them. Our 1/4 inch end mill, so everything is good to go. Now, and that's all there is to it. Now, what I want to do, one last thing that I want to do is I want to create a new layer here, and I want to turn off all the other layers for a minute, and I want to turn off all the toolpaths for a moment. Okay, I'm going to have a blank sheet, and I want to explain this. Okay, when we are okay, when draw my little 1/4 inch end mill. All right. With this job, the way I have it set up for myself is that Z0 is going to be my wasteboard, which represents the bottom of my material. Okay, that means I will not cut into my wasteboard, but that bit will raise up. When it's going to make the cut, it's going to travel. And as it's cutting through, the lowest that it will go is to Z0. So it's going to surely cut through all my part and just barely be kissing my wasteboard. That way my wasteboard doesn't get tore up. It just keeps it nice and lasting long. Other than the holes I'm going to be drilling into it, right? But with those holes, we're going to be drilling those holes 1/4 inch into our wasteboard, but it won't go beyond Z0. So when we touch off, because our job is set up for a 3/4 inch board, right? You know, and that's kind of the top. It knows that from 0, our board is 3/4 of an inch off. Well, since we're going to be drilling into here, the waste board for our alignment pins and not the top of this board, because we, you know, for the second cut, you know, then we need to, when we touch off, we need to change the Z, and we need to tell, you know, the controller program that this area here is 3/4 of an inch. So that way it thinks the Z0 is 3/4 of an inch down here. See if I can. It thinks Z0 is, you know, 3/4 of an inch down here that we're, you know, touching off. We're just programming in that this is 3/4 of an inch off. So that way it will, you know, come up and it will drill my 1/4 inch hole in the waste board where it should, because it thinks now that this waste board is this top of this board. So when we're cutting into our board, this is 0. The top of the waste board is 0. But when we're cutting into the waste board, the top of the waste board is 0.75. And that's what, when you touch off, you want to touch off and say 0.75. Now, if you're using the touch plate, and you've got a little touch plate that you're touching off on, our little 0.010 of an inch touch plate that you're using, then when you're drilling into the waste board, it's 0.76. Okay, you're 0.76. Got to add that 0.010 in there. All right. Any questions on that, guys? I know this was a long, repeated rinse and repeat, rinse and repeat. I mean, I just wanted to go through and show you how you look for those vectors, how you figure out what you're keeping and what you're getting rid of. If you know your part and what you've created, I know my drawers and what I've created. I know my cabinet side. You know what should be a groove and what, you know, what vector doesn't belong. You go through and identify those vectors that don't belong and get rid of them. You only want to keep the ones that you need to create the toolpaths for the operation that you need done to create that part. Any questions on any of this? Any questions on any of this? All right. Well, with that being said, let's get into a top view here. All right. Bear with me a second. You guys have, in the Facebook group, you have this SketchUp file of all the parts. You have a DXF file of the vectors, and the DXF files that I created for you I've already cleaned up. No vectors delete and all that, none of that stuff. It's all done. You just move them over onto your board and create your toolpaths. And then in the Vectric software, the Vectric file that I created for you, everything is cleaned up, everything is on its sheets, and all the toolpaths are already created for you. So those 3 files are in the Facebook group for you to download and use. This class tonight, even though we went and just recreated everything that was already given to you, this was a training in how you would approach it in case you want to start using SketchUp to create some designs to bring into Vectric. How you need to go through and identify the vectors you don't need and get rid of them, and then create the toolpaths on your parts the way they need to be created. So William asked, he says he joined late. A question on tabs, 2-sided job. You set it to 0.375 when you cut on the second side job as you cut the profile. Are you not cutting out the tabs? No. So let's take a look real quick at our. Let's go into our 3D view, and let's grab a 2-sided profile cut. So let's preview that selected toolpath. So a tab is created from the bottom of the cut up. My tabs are 1/8 of an inch, right? And actually, I probably should have went through and made them 1/16 of an inch, so that way they were only 1/8 of an inch after they were done. Now they're going to be 1/4 of an inch thick tabs. I might not want them to be 1/4 inch thick. I might go through and recreate those tabs. But needless to say, those tabs are cut from the bottom of the cut up. So let's kind of zoom in to here, and let's see if I can get focused on a tab. So that 1/8 inch tab is cut from the bottom up of this part, all the way through here. Well, when I copy these vectors to the other side, the tabs are aligned in the exact same place. The tabs are aligned in the exact same place as side 2. And so, therefore, when they cut, they're going to be 1/8 of an inch thick as well. And so, therefore, now what we're left with is, you can see there, I've got a 1/4 inch tab right there, from side 1 and side 2. So what I need to do is, I don't want a 1/4 inch tab. That's just too much chipping and chunking and all that. So I'm going to go back on all of my profile cuts, and I'm going to recalculate all of them to be for the tabs to be 1/16 of an inch tall, because a 1/16 inch on one side, a 1/16 inch on the other side is a total tab thickness of 1/8 of an inch, and that's all I want is a 1/8 inch tab, not a 1/4 inch tab. Right now they're 1/4 inch tabs, on this 3/4 inch material. But no, you're not cutting through the tabs because they're exactly aligned in the same place. So hopefully that answers your question, William. Hey, Larry. Good. Aloha. Hopefully you came in and you were able to. You're not just now joining because class is over. So hopefully you're Larry. So hopefully you're just not. You've been here for a while and you're been able to sit through the class. But I'm glad you're able to join in. Thank you. There's going to be another class Monday. Normally, Larry, the classes are on Monday night. We just had them Thursday. We had it tonight because we're going to be doing a whole new project on Monday, and I wanted to finish this 2-part project up. I want to finish it up this week, so you guys, if any of you decided you wanted to cut it, you could do it this weekend. So Ron says, on this 2-sided job, I don't quite understand the placement of the alignment pins. The placement of the alignment pins. Yeah, okay. So let's talk about this placement of the alignment pins. All right. So on my sheet, let me get rid of this so we don't see it on the other side. Okay. So on my sheet now, with this method, cutting the alignment pins partially through the material and then partially into the wasteboard instead of cutting all the way through the material right into the wasteboard. By doing it partially through, that means my holes do not have to be symmetric. They don't have to be in the corners. They can be anywhere. I could have a hole here and a hole here. I could have, just like I set mine for the 2 corners. I kind of like them there, and plus they're the only places that I had room on my boards when all the vectors are in there. I could have them, in various places. I only need 2 holes, alignment pins, and what they are is those alignment pins are there to help me when I flip my board over. Let's say I drill a hole here and drill a hole here. When I drill those holes and I move and I unclamp this board and I move this board out of my way, and now the board's out of the way, and now I'm going to drill those same holes but mirrored, because remember the board's getting flipped, right? It's getting flipped, but these holes are going to be mirrored. when I drill those holes in my waste board, when I flip this board over, I stick my little dowels in my holes on my waste board, and now I can just slide it right down and everything's going to line up perfectly. So on this side, I would take and I would copy these guys. Copy this one and this one to the other side. Copy to the other side. And now look what happens, there it's in this from left to right are the two holes, but my boards are getting flipped from bottom to top along the y-axis. So when I flip this board, look where my alignment pins are, right? And these are the holes that are going to get cut in the waste board. So now my pins that I put in my waste board will slide right into the holes that I cut in my project board, and it'll line me right back up exactly where I need to be, so I can run those cuts and everything's going to line up from one side to the other. So the holes are mirrored because you're flipping the board. They're mirrored. Ron, does that make sense to you? Do you understand that now? Ron, let me know if you understand what I mean. If not, I'll redraw it a different way in a three-dimensional kind of view. Let's do that. So let's see if I can three-dimensionally kind of demonstrate this. All right. That's hard. It's going to be hard to demonstrate that in a three-dimensional view. Thank you, Alan. Ron, you get it now? Okay. Because I was going to say, I was trying to figure out how I was going to draw it in a three-dimensional view. It would, it wouldn't be able to show very well in this manner. But when I flip my board over, I need to make sure that my board lands in the exact same spot. So on side one, I'm cutting my holes in my board 3/8 of an inch deep in this location. Okay? When this board gets all side one or all cut and everything, this board gets unclamped and moved out of the way. In the waste board, I'm going to run the side 2 alignment pin waste board file because it's mirrored. So I'm going to drill these two holes here in my waste board. That way, when I flip this board over, end for end, up and down, then my pegs are now going to be in this position when the board's upside down, and they're going to slide right into those holes, and it's going to line me up perfectly. All right, so hopefully that makes sense. So William says, alignment pins, how do you ensure you only cut into the waste board once for handling all the two-sided panels, such as moving from sheet 7 to 8, thus only one set of alignment holes in the waste board? Well, William, we created toolpaths for every one of the two-sided sheets for alignment pins. So if we needed to, we could just carve each of the alignment pins holes for each sheet, just in case we were off or something, when we're clamping from one sheet to another. If I'm free clamping, because there's no guarantee that I'm going to land in the exact same spot for my XY. However, if I set up a jig on my table, that bear with me a second. Oop. if I set up a 90-degree jig on my table of some sort, it could be whatever, that my board is every single board. When I zero out on this bottom left corner, right? When my bit is zeroed out on this bottom left corner, my XY0, it's going to be the same every single time for every single sheet that I do. Then I only have to set my X and Y one time at the beginning of this whole fiasco. If I don't have some kind of jig on my table, then I need to set my X and Y for each sheet that I do. Each sheet is like its own independent job, right? But if I set up a jig on my table that will guarantee that each sheet lands in the same spot every single time, and my X and Y is going to be the same every single time, then I only have to set my X and Y one time. And therefore, if that's the case, my XY is the same, I'm working off the same start point every single time for each sheet, then when I carve my holes from side 2 onto the wasteboard, that means that those alignment pin holes will line up for every single sheet that I did, because when I created my alignment pin holes, I created them using guides at specific measured points, a ½ inch in from this corner, a ½ inch in from this corner, which means I'm going to get a hole a ½ inch up here and a ½ inch down here, that when I flip this board over, that it will fit right in every single time for every single sheet. So I only have to drill one set of holes if I have a jig, if I have some way to guarantee that my X and Y will not change from one sheet to another, then I only drill one set of holes. If I don't have a way of guaranteeing that, then I need to drill each set of alignment pin holes for the wasteboard for every single sheet and treat it as an independent job. Okay? All right. All right. William, let me know. That was the answer for your question. Yeah. Because every single sheet, I use the same 2 guides to create my alignment pin hole placement. ½ inch off of each edge, I created my alignment pin hole pin placement. Okay? As long as my sheets are all the same size, which they should be, 23 by 17, and I've got a jig of some sort guaranteeing that my X and Y is the same exact every time, then I could just drill one set of alignment pin holes for my wasteboard, and I'm set to go for that whole job. On X and Y alignment with a different size end mill, how do you ensure that you are at X and Y? All right. So, William, the center of a bit, the center of the bit, the center of the router bit is zeroed out over the corner of the board. This circle, this pink circle represents a bit in my corner of the board. This is zeroed out on the center. If you want to be dead nut sure that you're right there on that corner, there's a lot of ways that you can do that. One is use something like the DWC quick set jig, right? Because it finds that bottom left corner. Or 2, get a V bit and put the point of that bit right on that corner, and zero out your X and Y, and that's XY0. Doesn't matter if it's a V bit, a 1/4 inch end mill, ½ inch end mill, because center of the bit is center of the bit, no matter what. If you're like, oh, I can't eyeball the placement of my, what if my 90-degree V-bit is off or something like that. Well, if you want assurance, you can take and get a 1/4 inch end mill or an alignment pin or something, and you can touch it up against this fence All right. If I set my board in here and I know where my corner is going, I can pencil mark it, whatever the case may be, know where my corner is going on my jig. I can come over here and I can touch off, and I can zero out my machine that from this point here, from this fence, you know, on my y-axis, this fence is 0. Okay? This fence, my bit, edge, I want my center, right? But if I'm touching my edge up against it, what's my diameter? If it's a 1/4 inch, then I'm 1/8 of an inch. I'm right now sitting at positive 0.125. Positive, so I type in positive 0.125 in my y-axis. Okay? So that way when I bring it to 0, boom, it moves it down there, right? So now I can take that pin or bit or whatever, and I can move over here and touch off on this fence, and I'm sitting at positive 0.125 on my X. So I type in positive 0.125. That way when I zero out X, boom. And when I tell it to go to XY 0, it's going to bring me right to exactly where I need to be. Okay? You with me? All right. So, yeah, Vern, that's given. You want to make sure your sheets are pretty much, you know, cut square, correct? You know, and not necessarily. If I didn't have the jig there, you know, if I set my X and Y here, and I drill my alignment pins in the same, you know, this here and here, and then I flip it over and I drill them mirrored on the wasteboard. I can move that jig out of the way, and I can flip that uneven, unsquare board over, and you know, because my alignment pins are working off my XY 0, I can still align, but you want to make sure that you're 90, you know, 90. That's what the fences are for. That's what the jig is for. But William, hopefully that understand. Yep. Yeah. So you want to cut your panels, and you know it's a 23 by 17 inch panel. Even if you don't cut them on the same day, hopefully your table saw is, if you're using your table saw to cut down your sheet goods and stuff, hopefully it's pretty, you know, square. You know. Hell, worst comes to worst, you can take an oversized panel, put it on your CNC, and cut out a 23 by 17 inch square out of it, and you know it will be square. You know. So, no, not true, William. If you have the WDC Quickset, you don't need the jig in a sense, but even with my jig, I still use my DWC Quickset to you know, find my XY0. I set it right on the inside of my jig. That's why it's got that lip on it and all. It hooks right on the inside of the 90-degree fence. My bit will come over and touch, and you know, identify my 0 and all. But if you're, but you do need the jig, because you totally jumped two things. The jig is more so for the placement of the board on the table than the squaring of the board. We want to make sure that the boards land in the exact same spot so we can use the exact same alignment pin holes. If I just free clamped my board and I zeroed out with my DWC Quickset, it's going to nail me right on the corner of my board each and every time. But that doesn't mean that when that I can use the same alignment pin holes that I drilled yesterday on a completely different X and Y position, because I could have clamped my board an inch over to the left or, you know, down. The jig is just for placement on the table, position on the table. So you definitely would need that if you were going to use, if you're only going to drill one set of alignment pin holes in your wasteboard. You need some kind of guarantee that your boards are landing in the exact same spot every single time. So you would need the jig, even with the DWC Quickset. The DWC Quickset is just going to help you zero out your machine precisely on the corner of your board or your jig. Either one. All right. Did you get that? You got that? You guys got that? Yeah, right. No, yeah, William, but yeah, no, you're exactly right. You got to hit yourself just a little bit. Good way of thinking, but it was two separate things. The DWC Quickset is great for finding X, Y, 0 and Z 0 on your board, your corner, but that's different than using the jig to help for placement on the table, where our boards are always landing in the same exact spot on the table, so that when we flip it over, we're always going to be landing on the same exact alignment pin holes if we only cut our alignment pin once. So the jig is for placement, not necessarily for X, Y, 0. We're going to be zeroing off of that jig and off of that, but it's not. It's more so for placement to make sure it guarantees our boards are in the exact same spot every time. So. All right, ladies and gentlemen, I really appreciate you. Hopefully this was interesting. It might have been boring because it was kind of rinse and repeat. A lot of the vectors and the toolpaths and all, and 10 sheets of kind of the same procedures and all. But hopefully it was enough repeatability and all to, so you get it, so that next time if you try to create something in SketchUp and bring it in, you'll know how to take a look at your vectors and eliminate what you don't need, keep what you do, create the toolpaths off those remaining vectors, and cut your parts out. All right. Okay. All right, good. Ron, thank you very much. Ron, do you now, are we clear on the alignment pin hole placement and what they're for and stuff? I just want to make sure, because you said you were, but I want to make sure that you're not sitting there going, okay, I still don't get it, and let me know. Did you, if you kind of get it now? Because it's one of those things that's hard to kind of wrap the head around a little bit. But when you do it for the first time or do it one time, it'll make sense. And you're welcome, guys, for all y'all saying thank you. You're welcome, very welcome, and everything. But it took me the longest time to wrap my head around it, because what was getting me is the procedure, Ron and guys, is the reason why we're only cutting the alignment pins halfway in the board, and then we're cutting them in our waste board, is because what that does for us, it gives us the flexibility to be able to carve side one of that sheet on one day. And hell, if we had to put it off for a week or two because an emergency job came up or something, and we had like 10 other jobs we had to get done, and then 10 days later or something, we wanted to come back and go, you know what? Actually, we need to finish up that project. You could literally come back and you can zero out your machine anywhere, X and Y, pick a spot, any spot, X, Y, 0, zero out the machine, and you can run the wasteboard hole toolpath from the X, Y that you zero out. Drill those 2 holes. You can take that project board, you can flip it over, and you can drop it down on those pins in those holes, and it's going to line you up perfectly for that XY that you just created, because those alignment pins are created off of those toolpaths are created off the same XY point. Doesn't matter where that XY point is, and it gives you the flexibility of, instead of having to do everything in one day, hell, you could do it weeks from now and still get perfect matching results, because you're always working off of your XY. Whether it's today or tomorrow, this hole placement right here from my X and Y is always going to be, whatever my position is, half inch along my X and 1.008 from there, from my 0 point, my corner. So I don't care if I set my table up to X, Y, and zero it out right over here. I can run that second toolpath and drill it. And that hole that I drill here and the hole that I drill in the corner is always going to be half inch on the X, 0.1008 on the Y. So it doesn't matter, what day I do it. my holes are going to line up with my pins and everything. So, yep. William, I did not talk about the bit tray holder that is numbered or anything like that. And I haven't even created it yet. So what I'm going to do is that will be just a bonus file that you guys are going to get. I will create a bit tray holder for the top drawer, bottom drawer, whatever it may be. I will create it'll be a separate Vectric file. I will send that over along with DXF or what have you for you guys if you want to make one. No, we didn't cover that at all. So that's going to be a separate project. That'll be most likely carved out of a solid piece of wood, a block of wood or something. But I did not cover it in this class. But I will create that file and I will provide it in the Facebook group for all of you guys and girls. Thanks for the reminder. I actually forgot about the bit tray holder for one of the drawers. All right. Okay, ladies and gentlemen, y'all have a great night. We're going to go ahead and say goodbye, and we're going to leave it at that for you all. All right. I appreciate you spending so much time with me. And hey, Monday, if you're still with me, if you haven't hung up yet, Monday, we're going to be doing our chair to ladder project. Chair to ladder conversion project. It'll be a pretty cool project. So that will be Monday night's class. We're going to make that cool project. It's a fun one. Step stool, chair, leaning bookshelf. It can be used as all kinds of things. A nice little decorative part of your office or something. Okay, guys and girls. Yes, what I will do, William, is I will go through and update the tabs to thin them out, and I will repost the revision of the file. So the file that will be available for download will be a revision. I'll post that as a revision. So you'll see that post here in about an hour. In the Facebook group, you'll see that as a revision. I'll just make a note in the post in the Facebook group that it's a update on the tabs. Okay. All right, guys and girls, y'all have a great night. Thank you very much. Good night.